perfect. All right, and again, go ahead and mute yourselves just so everyone can hear clearly. All right. So again, thank you all for coming. I wanted to first start off by introducing myself and Volunteer Science. So my name is Jason Radford. I'm the CEO from Volunteer Science. My background is in sociology. I just finished my PhD back in 2019. Volunteer Science was originally created at Northeastern University, where I still am a research scientist, was a postdoc. We spun this out as a company to try and create a future sort of life for the technology here, so that we didn't create it and have it go into the waste bin of history. So I've been working on Volunteer Science, doing online experiments for almost 10 years now. We started it in 2014, so 8 years, just shy of 10 years. So today is meant to be somewhat of a distillation of a lot of that, but it's also meant to help people who are just beginning, just new to experiments, understand sort of the core decisions that you have to make, particularly when it comes to doing online experiments. So a lot of this is actually going to be pretty generic to experimental methods in general, but there will be some things that are specifically tailored to online experiments. Before we get started, I want to ask a couple of questions just to get a sense of who I'm talking to, so I can tailor this a bit more to your sort of current position. So the first question I have for you is, what's your role? Are you a student, faculty, postdoc? So give me a sense of who all is here. That's great. It's like mostly grad students, and I'll share this out. Okay. So we're slowing down here, and I'll go ahead and so mostly grad students, some faculty. Perfect. Thank you so much, everyone. I think I can share the result here. Cool. So you see, it's mostly graduate students, some postdocs, faculty. So perfect. Thank you all for that. The other thing I want to ask you is, where are you in thinking about an experiment? So I'm going to go ahead and launch that survey. The idea here is I just want to get a sense of, I'm interested in experiments, but I don't know what I'm doing yet, all the way up until I know what I want to do, and I just need a little bit of, I'm ready to get going on this experiment. And thank you all for your responsiveness. We already have 71 responses, so thank you. Make sure one's in the waiting room. Okay, it looks like it's all slowing down. So I'm going to end it and share the results. So it looks like it's pretty evenly split across the different options, though more people are ready to work on the experiments. So that's very helpful. Again, thank you so much for taking the time. Okay, so let's get started.
You have snack.
There we go. All right, so what is an experiment? I think most people think of an experiment, or when we talk about an experiment, we use it loosely when we're not being too reflective about how we use it. When I often use the word experiment in everyday conversation, I'm really sort of thinking in terms of what you see here with this XKCD comic. We're trying something new, and we're going to see what happens. Right? That's I think what most people initially think of when they get an experiment. What happens if I do this? What do I get at in response? And what we're really going to focus on today are controlled experiments. So it's not about sort of poking the world and seeing what happens, but controlling a variable. So we're going to manipulate something. We're going to give you one version of it or another version of it. And we're going to give different people those manipulations. So there's a manipulation, there's a treatment to groups of participants, or usually groups of participants, and we're going to measure the outcome as a difference between those groups. They're continuous variables, so it's not necessarily always multiple groups. But here we're focused less on poking it and seeing what happens, and more of a controlled experiment of giving some people something and some other people another thing, and looking at the different results between those two groups. So this is basically the outline of the talk, going through the different components of the experiment. So step one is just creating the treatments. What do you actually want people to do? The next thing is defining the grouping and assignment procedure. How do you want to assign people to different treatments? And what level of group do you want to use? And I'll go into different kinds. Let's see if I can do this. Here we go. Again, if you are not muted, go ahead and mute yourself now. After you've figured out your assignment procedures, you want to identify your sample size. How many people do you need per group to run the experiment? And lastly, you want to measure the outcome. So how do you know that there was an effect, or at least test whether there was an effect or not? And please, if you could mute yourself. For whatever reason, Skype or Zoom is not sorting this by who is audible. So I can't very easily find out who's making noise. I appreciate the help. Okay. So first, let's talk about creating a treatment. There are a lot of different kinds of treatments. I create 6 buckets here. And I'll go through each one of them, so I'm not going to spend too much time talking about all of them here. But the first thing you want to do is figure out how you want to deliver your poking of the world. So I think one of the most common one, the easiest one, is a survey experiment where you ask one question in different ways. In political science, it's a very classic experiment where you ask people, or you ask some people, do you support welfare versus do you support assistance to the poor? And generally, people in the United States are much more supportive of assistance to the poor than they are for welfare, even though politically speaking, they are the same policy. So in this case, you're just asking different people the same question, but in different ways, very frequently. Another way to treat people is with different resources. So giving people more time or more money, or in some cases, having more people work on the task. But one of the unique things about resources is that it gives you a continuous treatment. So you can give people the question of, do you want to raise welfare by $20 a month or $2,000 a month, and anything in between? You can sort of create a random number generator that gives people those options. And that has inferential differences later on that I'll talk about. Same thing with time. People make different decisions when you give them different amounts of time. If you give people 5 seconds, you'll get that immediate answer. Versus if you give them 5 minutes to think about it, they'll very often give you a different answer. The next one, really common again in the social sciences, are vignettes. So these are stories that you tell about a situation. Very frequently in political science as well, you can give people like different campaign advertisements. So different flyers or different videos. I sort of lump all of these in as vignettes. And you ask people to respond to them. So on the left-hand side, Mary is a single mother who receives assistance. On the right-hand side, Mary is a single mother who receives welfare. Then you can ask people, what do you think of this? What do you think about Mary? Jonathan, it looks like you're not on mute. No. I'll try to find it. Again, with a large room, I can't force everybody on mute. Okay. The next thing that you can do, and this is, I think, really where you get the broadest variety, and you end up getting the most complicated experiments or tasks. You get people to try to do something, and you change the thing that they do. In this case, the simple version is, again, you have 2 vignettes, but you're having people decide whether they want to vote to raise assistance, as opposed to simply asking them their opinions. If you were a legislator, would you raise assistance or would you raise welfare by 7%? Other tasks would include the prisoner's dilemma task, a Stroop task, simulated markets. Tasks is a huge category of experiments. But again, what this tasks framework allows you to do is more realistically model the world and give you a bit more complex intervention. The last thing I'll mention on treatments is a multi-person treatment. So again, you can give people vignettes or surveys, but then you have them respond to it or do the task as a group. So you have a group of 5 and they have to pretend that they're a legislator and they're going to vote as a group of 5 on whether to raise assistance or raise welfare and see what the differences are between the two. Jonathan, can you please mute yourself? I'm having. Yeah.
Okay.
So I'm going through the Zoom attendees here. Not finding him. There we go. Okay, there we go. Mute all. Okay. All right, there we go. All right, so types of controls. So when we're thinking about treatments, we're thinking about how do we present one group with one option and another group with a different option. Here, we want to define what that other option is. So sometimes it's a null. So sometimes there's no intervention whatsoever. We're going to have people do a survey and we're not going to give them a story. And we just want to measure baseline. Are they interested in raising welfare or not? And then some people are going to get a story about somebody who collects welfare. So there's a null. You get no intervention. Another alternative is a baseline. So in this case, we're comparing it to some sort of alternative treatment that we have a sense of is either like the normal treatment that people get, or is something that we consider to be a taken for granted treatment that if they weren't going to receive the intervention that you would give them, this is what they would probably receive. Think is a good baseline. The last one is a placebo. So placebos are different from baselines, and the baselines are generally legitimate, quote unquote, treatments. People would normally experience it. A placebo is a fake intervention that should trigger 0 response, but could trigger a response either because of social desirability bias, or placebo has actually its own effect. If you're doing medical trials and psychological trials, people will change their behavior just because they think they're being treated, independent of social desirability. So when you're thinking about the kind of treatment that you want to use, the type of control that you want to use, the way that you answer this question is you think about, it's a theoretical question. You think about what is the appropriate group of comparison? Is it no intervention? Is it some set of alternatives? Or is it sort of a self-imposed intervention, a placebo? Do we need to test for people's ability to create the effect themselves? Okay, the next thing you want to do is define groups. So we have treatments. We have 2 versions of the survey, 10 versions of the survey, and got to figure out how we want to allocate people to different treatments. So there are 3 different kinds, generally: a parallel group, factorial, Bayesian. I'll go into each of these. So in a parallel design, the groups go into one or the other treatment and they never interact with one another. They never interact with the other treatments. In this case, group 1 receives no treatment. There's sort of a null baseline group. Group 2 gets treatment 1. Group 3 gets treatment 2. This is parallel because they never overlap in treatments. This is the most common. This is the A/B test, essentially. Now, a factorial design, people do, or treatments can overlap. So what you have here is just you're adding in a 4th group where you're receiving treatment 1 and treatment 2. What you want to do with factorial designs is test the interaction of treatments. So sometimes you want to, a lot of what we do is gender-based experiments. So we change the gender of the people who are in the vignette. So change the gender of the person and what they're doing. And the factorial design allows us to look at the intersection of gender and the action that they're taking. So that's a factorial design. Now the problem with factorial designs is that they get really big, really quick. So if you have 6 treatments, we want to test the gender of the person who's acting, what they're doing, whether they like what they're doing, and whether they get paid for it. That's 4 factors right there. And there could be, we could use 3 genders, obviously male, obviously female, and then a gender neutral person. So that's 3 categories of treatment 1. So getting at the problem here with factorial design is they get really big, really quickly. So what you can do is you can do what's called a fractional factorial design, where you don't test all possible combinations of the treatments, but you test the ones that are most theoretically relevant. And here, what we want to see is, how do people experience each individual treatment, and then what happens if we give them all of the treatments all at once. And this is a binary fiction, but what this allows us to do is gets us out of the having to test 2 to the 6 different factors. So fractional factorial design is a good way of cutting down the space of experiments. One thing that you can do if you don't have tons of participants, if you've had 8 groups and you need 50 people per group, that's a lot of groups. It's 400 people that you need to recruit just for this study. So what do you do if you don't have a lot of participants? Sometimes you can do what's called a crossover design, where the same group gets multiple treatments. And what you do is you alter the timing of the treatments, often adding in some neutral time in between treatments for people to recover from the effect of whatever the treatment is. This is only advisable when you have a theoretically robust reason to believe that the treatments are independent. If they're not independent, you can randomize the order, but then you lose the most efficient part of the grouping process. So if you want to do different randomized orders, you still would need 3 or 4 or 5 groups to test different orders. But this can be helpful if you don't have a lot of participants, but you have a lot of treatments that you want to test. The last thing is what happens if you have tons and tons and tons of treatments. And by tons of treatments, I mean thousands, right? If you're not Facebook, but you could be in a situation where you are trying to determine the most effective. This is something we've actually done, or one of my collaborators has actually done, is test the persuasiveness of thousands of different messages. And so rather than having each person get into a group where they see one message, you want to efficiently search the space of thousands of messages. These are what are called Bayesian optimal experiments. And what you're doing is you're not trying to get 40 people or 60 people or 100 people in every one of these cells. You're not trying to conduct a valid experiment in every cell. What you're trying to do is quickly and efficiently search the space for the places where you're most likely to find effects. So you may miss some little spots where there is a huge effect. It's not going to be a comprehensive search of all possible treatments. But what this does is it allows you to find some of the bigger effects without having to recruit the full sample. I won't go into the math behind this, but essentially what you're doing is you are running a couple in every one of these squares, and then using the initial information, you find some spaces where there's some big effect or some potential effect, and you keep adding in more participants until you get a sense of whether that big effect early on was influence, or it holds up over more participants. It's a very crib node version of that. But that's there's a new approach to optimizing large scale experiments like that. Happy to point you to readings if you're interested in that. So those are the ways that you can split up your experimental treatments. The next thing I want to talk about is randomization. How do you get people into your parallel groups or your factors? There are 4 basic approaches here. There's actually 5. I'm not going to talk about stratified sampling. I'll mention it, but I won't talk about it separately. Mostly because it's kind of difficult to do wholly online. So simple randomization is a flip of the coin, a roll of the dice. Somebody comes to your experiment from Mechanical Turk, from Volunteer Science, from Pure Spectrum, what have you, and you flip a coin and you send them to the experimental treatment that matches the heads or tails. In this case, there's 4 options, and they can go play tennis, golf, cricket, or baseball, right? So that's simple randomization. Most studies use simple randomization. Imbalanced randomization is when you need people to participate in a particular condition more than would be even. There's some conditions that they need to be selected oversampled into. There we go. All right. Next one is block randomization. So block randomization is one of the problems that happens with simple randomization is there's variance. Sometimes the coin flips heads 4 times in a row, and you end up with 4 people playing tennis and only 1 person playing golf. And that can happen at the end of 100 flips. You just have 80, or you have 40 people playing tennis and only 10 people got selected into the baseball condition. So you get less information about some conditions. Block randomization ensures that you get an equal number of participants per group. So in this case, let's just assume we have 4 groups. What's going to happen is I'm going to send some person in from Mechanical Turk, what have you. They're going to get randomly assigned to group 1, 2, 3, or 4, but they're not actually going to go and start the next one. We're going to wait till the next person comes in, and we're going to assign them randomly. I did this in order, but they're going to get randomly assigned to a group of the remaining 3. Next person comes in, we assign them randomly to the remaining groups, and then another person comes in and they get assigned to the last group. And once we have all 4 people randomly assigned to one of the 4 groups, then we send them all to their study. Again, what this does is allows you to ensure balance in the number of participants who get recruited to each condition. It also allows you to mitigate some of the temporal effects of people showing up early or showing up late by having people matched up together. Okay, last thing I'll talk about if you're doing multi-person studies is cluster randomization. So with cluster randomization, the question is, how do you allocate people to groups randomly? Do you, randomly send them to room number 1, and then you show whoever shows up to room number 1 gets condition 1, or do you put people in a group and then send them into a condition? With cluster randomization, what you do is you put them in a group first. So you wait till 3 people show up, and then we roll the dice, however we want to roll the dice. You can do cluster block randomization if you wanted to. But you show up as a group and then you allocate the group to a condition. I focus on this version because if you're doing field experiments, this is typically what you do, or with your doing experiments with existing groups. So like classrooms in a school, or if you were doing an experiment in one of your classrooms, you had existing groups of students doing some project together. You would randomize the project teams, not the individuals. So that's what cluster randomization is. All right, so now we have the treatments that we want to create, the groupings that we want to use to estimate differences in those treatments, the randomization method that we want to use. Now the question is, how big should the sample be? How many people, units of observation, sometimes it can be groups, should be in each treatment group? I'm going to give you the basic answer. There's a more complicated answer based on changes that values that you have around power and significance level. But if you're just creating an experiment and you don't know the answer to this question because you either don't already know the effect size, or you're not sure, you don't have a very strong opinion about the significance level that you want to reach or the power that you want to get, these are the standards. So the significance level when you're doing power analysis starts at 0.05. That's the standard. And this is just your type 1 error rate. The chances you're going to hit a false positive. Again, you can go higher, you can go lower. Generally, you don't publish if it's lower, 0.10. But again, this is sort of the standard starting points for power analysis. The next thing is what's technically called power. This is 80%. This is the false negative, or the false negative rate is significantly 20%. You have a 20% chance of having a false negative, but it's set in terms of 80% power. This is also known as recall and sensitivity. So if you're coming from machine learning, this is technically recall. But this is, again, the chance that you're going to hit a false negative. And the false negatives and false positives are not arithmetically related. So 80% power is not the same as 20% significance level. The last thing that you want to figure out, this is the most important thing for you as the researcher, is what is your effect size? But most people, when they do an experiment, you're not replicating something, you're doing a new experiment and you have no idea what the effect size is going to be. You're generally shooting for one of three buckets: large, medium, or small. And a large effect size is a t-test of 0.8. If you're like me, I'm more used to correlations. If you're doing continuous observation, the correlation of 0.5 is considered large. A medium effect size has a t-value of 0.5 with an r of 0.3. And a small effect is a t of 0.2 and an r of 0.1. Now, what you want to do when you're trying to figure out how big your sample size should be is answer the questions. How much power, how much statistical significance, and how big of an effect do I have? So with the power calculation, what you want to ask yourself is, how sure do I want to be that some effect exists? I don't need to necessarily be precise in it being my effect, but I want to be able to confidently reject the null, that there's nothing here. Conversely, you increase your statistical significance if you want to make sure that your effect exists, that your treatment moves the needle here. You want to be able to be clear that you are finding something. The last question, personally, I don't mess around too much with statistical significance and power, just because you don't, it's not necessarily clear. And if you have the money to run thousands of people, this is the less precise part of it. What you really care about is how big is your effect, because there's less that you can do with the size of your effect generally. Or you have more control, but once you've set it up, you're sort of stuck with it. So the question is, can you create a really big effect? And by big effect, this 0.8 t-value is taken to be the difference in height between 13 and 18-year-old girls. Like it's visible to the eye, both in terms of in the world, but also when you're looking at the distribution plots. The distribution of girls who are 13 is overlaps a little bit with girls who are 18, or the difference in needs is very obvious. Now, a small effect, this 0.2, t of 0.2 and an r of 0.1, is barely visible in the data. So difference in height between 15 and 16-year-old girls, it's there, but it's not big. And if you're eyeballing it, it's hard to tell exactly if it's really that statistically significant. So when you're developing your treatment and trying to assess the sample size, I always tend to develop treatments that are going to give me big effect differences, because it makes it a little easier to detect that the mechanism is there in one form or another. And it also reduces the sample size constraints. So let me show you what that looks like. So if you're just doing your basic power of 80%, statistical significance at 0.05, these are the sample sizes you're going to be shooting for. So with large effect sizes in a group treatment where you have people in two groups and you're just doing a t-test, you need 26 people per group to identify a large effect. With medium effects, you're going to need 64 people. So as soon as you start having small effects, the group sizes go up. The last thing is small effects. 394 people are needed in each group to identify a small effect with an 80% power and a 5%, yes, statistical significance below 5%. If you're doing a continuous study, so you have a treatment that is continuous, these numbers go down a little bit. So there's only one group in a continuous treatment, just high and low. You only need 29 people to test a large effect. That's not 29 per group, it's 29 subjects in total, because it's just one continuous treatment. In a medium size, you need 84 people. And then a small for 0.1, you actually need a ton of people to get a small treatment. But this, I think, what I'm doing here is I'm sort of going to show you, one, what you should expect going in. How many people do you need for the size of the effect that you're measuring, trying to get at? And so that you understand where you have the most control over the results of your study. If you can design a study that has large effect sizes, you can really save on the subjects that you're recruiting. Okay, one quick note. If you are somebody who is doing something in a well-established area where you know the effect size and you know the standard error, there are calculators in every programming language that will take that effect size, that'll take that error and spit out the number of respondents for the power and statistical significance. I won't go into those formula because it's too weedsy, but if you're already there, I'm happy to point you to those. But that's relatively easy to find. Generally, most people have this problem of not knowing how many people they need to recruit when they don't know the effect size or the standard error. Okay, next thing that I want to talk about is, now that you have your subjects, you have designed the experiment, how do you actually find out if it worked? What are the ways that you actually estimate the treatment effects? Because it's not, there isn't just one way. So when you're doing this treatment, you have 4 conditions. There are, I think, 8 if you're doing field experiments with people who may be able to get access to the treatment without you giving it to them. This is a more focused on lab experiments where somebody can't get access to the treatment if they weren't given it by you. So there are people who are assigned to the treatment group and actually get the treatment, called the compliers. There are some people who are assigned to the treatment who don't take the treatment. And in this case, you can think of people who didn't see that the word was welfare, right? Or didn't see that, for us, we do the gender experiments. They didn't recognize the name as gendered, so they don't recognize that Mary is a female name in English, for example. That would be somebody who would be assigned to treatment but didn't take a treatment. On the other side, assigned to control or assigned to alternative treatment, if they were assigned to the control but they somehow took the treatment. Non-compliers, and they didn't take the treatment, they're compliers. So what you want to do generally, there we go, is compare the assigned to treatment versus the assigned to control. And the effect for those who were treated minus the effect of those who are controlled or given the control is your what's called average treatment effect. And you include non-compliers here in part because you want to be able to study what happens for people who even don't necessarily see the treatment. But sometimes if you're giving people a treatment and they don't experience it, that's just something that happens in the real world too. Some people, if you're doing a field experiment where you're giving people $500, and they lose it, or they don't get access to the bank account, or they don't spend it, they don't cash the check initially, right? It happens. So you want to get a sense of average treatment effect for everybody assigned to treatment, because when you go out as a policymaker and then try to give everybody in the world $500, those people are going to lose their checks too, or those people are going to not claim the checks. So you want to get that average treatment effect for everybody who you attempted to treat, you intended to treat. Alternatively, you can look at the effect of treatment on the treated. So again, there's a theoretical question here. Which one do you actually want to know? You want to know, what's the effect given this intervention that we created versus what's the effect given the people actually received the intervention that we created. In this case, what you're looking at is what happens to those who got the treatment and were assigned a treatment versus those who were assigned to the control and didn't receive the treatment. When you're doing an online experiment, a lot of what you can do here is actually ask people questions. Did you see the treatment? Did you understand the instructions? Did you, what gender do you think Mary was, right? Most people should be able to answer these kinds of basic questions. And that's one way of, in an online context, getting a sense of who actually complied, and gives you a difference from average treatment effect to local average treatment effect. Last, I want to talk about heterogeneous treatment effects or group effects. What's called the conditional average treatment effect. We're in this world where causation and estimating cause in the social sciences is becoming incredibly popular and technical, and so the language around this is evolving. So conditional average treatment effect is the average treatment effect for some subgroup of the people that you tested. So on the left-hand side, we have your normal average treatment effect, where you just look at everybody who was assigned treatment versus everybody who was assigned control. Conditional average treatment effect, you just take some group. So all of the women in the study who were assigned to treatment versus assigned to control. See, is there a difference between the women who were treated versus the women who were not treated? The challenge, of course, with this, as could be indicated by the last segment, is that you have to have enough people in your subgroups to do this analysis. So very frequently, you don't see a lot of heterogeneous treatment effects being estimated when somebody does a study of only 50 or 100 people, because you typically don't have a subgroup that's large enough to do these statistical effects with enough power. But if you have a big experiment, or you have big subgroups, or you want to try to calculate the heterogeneous treatment effects for particular subgroups, this is how you do it. And you can also do a conditional local average treatment effect too. All right, the last segment here, you build everything up, you know which study or know which estimate you want to try to create. So the next thing we want to talk about is recruiting from online pools and making sure you get the best data. So there are two basic kinds of pools. One is the paid pool that most people use, like online worker pools like Mechanical Turk and Prolific. There are other aggregators like Lucid and Pure Spectrum that take people who are signed up either to get paid to do studies or who get these points that they can turn in for like coffee mugs or T-shirts or other stuff, and they will send you to your study, and they do the studies so that they get paid or they get the points. On the right-hand side, these volunteer pools, these are people who you are recruiting or are pre-existing somewhere else. There's a group of people who you can reach. And they come in to participate in the study because either you offer them study payments or because you've motivated them to participate for free. To volunteer science, we have a volunteer pool. Nobody expects to get paid. They're doing it because they like contributing to science. If you're on social media and you're doing online ads for Facebook and you're saying, hey, come take this survey for 5 minutes, same basic kind of population type of pool. You can, of course, also build your own where you take a bunch of contact information from voter files or recruit people from your classroom, right, to participate in your study. But this gives you a sense of there is a binary differentiation between those who are participating because they're getting paid and they want to basically finish as fast as possible. Versus those who are doing it because they've been convinced to do it using an intrinsic motivation. So either way, okay, it's a question in chat, 1 second. Yeah, differences and advantages with online workers and sample aggregators. That is a great question. And for the paid pools, there are international pools. So Prolific is international. Pure Spectrum has folks internationally. I think Lucid also has an international sample. So it's not only for US citizens that you can set limits. So if you wanted to do US recruitment, you can say Mechanical Turk only in the United States or Pure Spectrum only in the United States. All right, so sample aggregators, two big differences. One, sample aggregators, you can't guarantee that somebody's actually getting paid for the study. So you're basically paying Pure Spectrum $1 or $2 or $5 to recruit somebody. And the people who are actually doing the original recruiting, sometimes they're paying those people. Sometimes they are simply just giving them, again, the rewards for coffee mugs. With online workers, you're guaranteeing that person gets paid the amount that you told them that you wanted to offer them. So if you're doing an economics experiment where you really need to make sure that that person's going to get $5, right? Because you told them that they're going to get $5, you have to use the online workers. Sample aggregators, you can sometimes pay people directly, but it's not always guaranteed. The other big difference is that the sample aggregators are typically a lot bigger, and they have a lot more existing data on their subjects or participants. So you can do a lot better targeting. Prolific is really good about giving you a lot of targeting information, but generally you get a bigger sample with more targeting information from a reseller. Quality. I don't know if I've seen any good comparisons in quality between sample aggregators and paid worker pools per se. I've seen some validation studies on paid worker pools comparing Prolific and Mechanical Turk to one another, and comparing them to like a baseline lab. Generally, Prolific comes out better and closer to the lab than Mechanical Turk. My guess is because those people are only participating in research studies. And so you're not getting the random Turker who's used to like classifying images or doing some other kind of a smaller task, not research related task. Prolific is also expected to be research, and so I think that there's a little bit better framing what happens going in. But yeah, so this is, I think, the best practices here, I think, do get around some of, not get around, but help address some of the quality questions, with Mechanical Turk, with Pure Spectrum, with Lucid. I'll say in general too, with resellers, I tend to see more rejections in participant quality than with Mechanical Turk or Pure Spectrum or Prolific. With the resellers, because people aren't getting paid, there's less of a commitment to getting it done accurately. Whereas Mechanical Turk, they're going to lose $1 or $2 or $5 if they, miss an attention check or mission instruction check. So let me get to that now. I think these are all good checks to have, no matter what population you're pulling from online. You would be surprised that people do use bots. We've had one case at Volunteer Science where nobody gets paid on Volunteer Science, but for whatever reason, some random bot network, we never were able to figure it out. Like, try to answer a survey of ours once. Nobody got paid. It never happened again, but for whatever reason, we had like 200 submissions of the same survey over like a day or something. It's very rude. So it never hurts to have these checks in place, no matter what your recruitment you're doing. But the first thing you want to do is put in instruction checks. And what this does is that one, verifies that people are reading and that they understand what you're asking them to do. This goes back to the making sure that people are actually receiving the treatment. But it's also making sure that people are paying attention. A bot that's like randomly checking through is going to just by happenstance fail an instruction check because they selected A instead of B. So instruction checks are really good. Attention checks. So an attention check is just making sure that people are reading the text. So it can be a single question that's just like, hey, we're going to make sure that you're paying attention. Please select A. Again, that'll help filter out bots. It'll also help filter out people who are just clicking randomly. There's a bit more of a subtle attention check where you give people like this narrative question that fits the topic of your survey. So say you're doing a survey about media and you say, in September, Fox News reported on, so and so and so, but in the middle you say, okay, this is an attention check question, please just select A. And then the options are like, MSNBC, CNN. And so it looks like a normal question, but within it, there's an attention check. Those are a bit more elusive and harder for people to skip through. But they also tend to catch volunteers who are trying to read in good faith. Not that you shouldn't do them, but the takeaway is that, at least with attention checks and even instruction checks, you don't want to just throw that data away. And you don't want to kick those people out because there's certain kinds of people who skip those or who miss those. So you're going to bias your sample, but you want to flag it. And then you want to be on the back end. You want to say, okay, here's the results for those who passed the attention checks and the instruction checks, and here are the results for those who didn't. That gives you a robustness check. Alternatively, when people fail bot checks, you do want to kick them out. So bot checks, you can do something like what do you call it? Like a reCAPTCHA or like the little button that says a bot check. I think Qualtrics has them now natively. The other thing that you can do is provide simple math or language questions. So in the text, what is 2 + 4? Right? Because a bot is not going to be able to read that and understand that you're asking them a math question. Alternatively, you can say, what is a synonym for a house? And you can say like a peach or a car or a home. So questions that a 5-year-old can answer is a good bot check question. And if somebody fails those questions, then you should kick them out. Mostly again because they're bot checks, they're not attention or instruction checks. Last thing that you can have is a quality check. This comes mostly from the computer science world where people are like tagging images or tagging tweets. And you want to make sure that you're getting people who are providing high quality data. They're not just take 2 seconds to think about, oh, is this a happy or sad tweet kind of thing. So what you're doing here with a quality check is you have some background knowledge about what the true answer is. So in this case, like again, you're tagging images. You know that this image, you've had 5 undergrads tag this image as happy, and you want to make sure that your worker on Mechanical Turk or your volunteer actually says that this image is happy, that they don't say sad or something else that indicates that they're not providing valid data. Usually when you're doing quality checks, you also kick people out. You pay them for the work that they did, but with the quality checks, what you're doing is you're making sure that you're getting good data and not junk, and you don't want to continue collecting junk data. There we go. This is where I'm going to point you to our YouTube channel because we have an entire presentation, a workshop just like this on recruiting subjects online that goes into different methods for recruiting subjects online, different best practices for recruiting subjects online. It is very thorough. I literally have spent an entire workshop hour talking about recruiting subjects online for experiments. So definitely go there and watch that. I'm just going to, I cribbed a little bit of that part of the talk from that one. So definitely go there and watch that if you're interested in recruiting subjects online. All right, so that's sort of it for doing online experiments or designing online experiments. I wanted to focus on a couple of upcoming tutorials that we have that are meant to show you some of the basics for how to actually do some of these things. And this is actually going to be focusing on using volunteer science to show you how to do these things, but you don't necessarily have to use volunteer science for it. So I'll show you how to do some of the, with randomization basics, we'll show you how to do the simple randomization and the unequal imbalanced randomization. We'll also walk you through creating a vignette experiment using volunteer science, and then show you how to create a task experiment. We have a library of tasks that you can use. And we'll show you how to tweak a little bit of one of those tasks and then deliver it to different groups of people. So if you're interested in those tutorials, do register. The volunteersci.activehosted.com. Actually, I'll go ahead and I meant to write this down. I'll put it in the chat. I have one more poll, folks. Okay. Oops. There we go. So that's the sign up form for the tutorials. They also come with free accounts. We give you a free account of Volunteer Science for attending the tutorials. You need it to test the vignette and try the stuff yourself. Last poll I have here. So one of the things that we're trying to do at Volunteer Science is teach you how to do online behavioral research, sometimes experiments, but not always experiments. And what we want to figure out is what is the way that you like to learn the most? Do you like long videos? Do you like workshops? Do you want to do a summer camp? So what I have here is a question that is, choose one. What is the way that you like to learn the most? Because this is going to help us develop new educational materials to help you get your get you the information that you need, the training that you need when you need it, in the way that you need it. And I appreciate your taking the time here. And once you're done with the poll, we're basically done. I'm going to sit around for a little bit and open up the chat. So if you have questions or something you want to see, let me know. I'm happy to talk more about recruiting folks online. If you have any questions, things you didn't see, anything that you wanted to see that you didn't see, let me know. Happy to talk about it and happy to point you in the right direction if I need to. So. And let's see, I will go ahead and share the, I'll end the poll and share the results. So it looks like people like the 1 hour workshop, I guess. I got some selection bias here. 30-minute tutorials, okay, that's good to know. Like I said, this is the 30-minute tutorial is what we're shooting for next. We are thinking about doing a summer camp that is more immersive. That's, really just kind of helping people or encouraging people to take a couple of days over the summer to really focus on getting a study done. Figuring out what they need to do, developing the thing, and getting it ready for subjects or recruiting subjects if you're ready for that. So I'm going to go through chat here and I will go ahead and stop the recording as well.